In this video, we'll talk about arc length for vector functions. So let's take a look at the formula. If we have a parametrized curve and f prime, g prime, and h prime are continuous, and the curve is traversed once for t between a and b, the arc length of the curve between f of a, g of a, h of a, and f of b, g of b, h of b is given by the integral from a to b of square root of f prime of t squared plus g prime of t squared plus h prime of t squared dt, or integral from a to b of the absolute value of r prime of t dt. So, knowing this, let's solve the first problem. An object moves on a trajectory given by r of t, right? It's a vector function, equals 10 cosine of 2t, 10 sine of 2t, for t between 0 and pi. So L, how far does it travel? It's integral from 0 to pi, right? Because t was between 0 and pi. And then this function is f of t, and this function is g of t. So let's calculate their primes first. F prime of t, it's equal to 10, and then cosine of 2t prime is negative 2 sine of 2t. So basically f prime of t is negative 20 sine of 2t. And g prime of t is 10 times sine of 2t is 2 cosine of 2t, so it's equal to 20 cosine of 2t. So replace them into square root of f prime of t is negative 20 sine of 2t squared plus g prime of t, that's 20 cosine of 2t squared dt, right? There is no third component. So it's going to be integral from 0 to pi square root of 400 sine squared of 2t plus 400 cosine squared of 2t. So I'm going to factor out 400, and I end up with sine squared of 2t plus cosine squared of 2t, which we know it's equal to 1. So we get integral from 0 to pi of 400, square root of 400, which is 20 dt. That is equal to 20t from 0 to pi, so it's equal to 20 pi. And this is the length of the curve, this one. So we have r of t, and this is f of t, so f prime of t is 1, we know we'll need that. This is g of t, it's 8 sine of t, so g prime of t is 8 cosine t, and this one is h of t, which is 8 cosine t, so h prime of t is negative 8 sine t. So the length of the curve is integral from 0 to 4 pi square root of f prime of t squared, that's 1 squared, which is 1, plus g prime of t squared, that's 64 cosine squared of t, plus h prime of t squared, that's 64 sine squared of t dt. Now, if we factor out 64 from here, we end up with sine square plus cosine square, which is 1. So we end up with square root of 1 plus 64 dt, which is square root of 65t from 0 to 4 pi. That is equal to 4 pi square root of 65, and we found our the length of the curve. Let's solve this example. Let's say we have the trajectory r of t. T is between 0 and 4, and we want to find the speed associated with the trajectory and the length of the trajectory of the given interval. So let's start with 1. First of all, v of t is the first derivative of r of t. So we get 2t, 6t, negative 10t. And then the speed associated with this trajectory is given by the absolute value of v of t, which is square root of 2t squared, 4t squared, plus 6t squared, 36t squared, plus negative 10t squared, that's 100t squared. So if we add all this up, we get 140t squared, which is let's say 140 is 4 times 35, so it's 2 square root of 35t. So part 2, find the length of the trajectory. So the length, it's integral from 0 to 4, as t goes from 0 to 4, of absolute value of r prime of t dt, which is actually integral from 0 to 4 of v of t in absolute value. So it's integral from 0 to 4 of 2 square root of 35 t dt, which means 2 square root of 35 t squared over 2 from 0 to 4. These two cancels with this one, so we end up with 16 square root of 35. It's the length of the trajectory between 0 and 4.